Hello class, today we're going to look at the laws of logarithms. In the previous video we looked at the properties of logarithms, and those become very handy to us when we are trying to simplify logarithms, and it's also going to be useful to us as we explain the laws of logarithms today. So let's do a little recap. Let's make sure that you still remember these properties. So the first one was log, let's call that 1. Log of base A of A, we said that was equal to 1. 2, log of base A of 1, we said that was equal to 0. The third law, or the third property, was log of A raised to the x. We said the outcome was x. Then the fourth one was A raised to log A of x. And we said the outcome was also x. So these are the 4 log properties that we looked at. And we also discovered this new logarithm called the natural logarithm, which is the ln. And we said that these properties were exactly the same if you are in natural logarithms. So let's put that alongside it so that you can see that it's the same thing. So this is going to be ln of e. Remember that it's got an invisible base, e. So ln of base e of e is equal to 1. Ln of 1 is 0. So ln base e of 1 is 0. And then we are saying ln e to the x is the same as x. And e raised to the ln x is the same as x. So these were the 4 properties. Okay. These are properties of logarithms. Now let's look at the laws. So there are 3 laws. Let's look at the first one. But before we do that, I'm going to make this declaration. I'm going to let x be equal to log of a m, and y is equal to log of a n. All right, so this is my declaration. So let's look at the first one. Let's look at the product rule. All right, so the product, as the word says, product, I'm multiplying 2 factors. So I have the log a of m times n, and I want to find out what is this equal to. Okay, so let's do a quick proof of how we arrive at the answer. And so with my new the declaration that I have above, let's do a little bit of manipulation with it. I'm going to switch them to exponentials. So I'm going to get x equal to log a m. When I switch it to exponential, is a to the x equal to m. And likewise, well, I'm going to put it down below, y equal to log a n. If I switch it to exponential, it becomes a y is equal to n. Well, I can do a quick substitution back into the log a of m times n. So log a m times n is going to be equivalent to log a, and if I substitute what m and n are as an exponent, then I get a to the x times a to the y. Now, looking at what I have over here, hopefully you can see that you can apply your rules of exponents to simplify this expression. So when you do that, you end up with log a of a raised to the x plus y. Now, if I rely on my properties, the very first property says, not the first, but the third property says log a of a raised to the x, the outcome is x. I think I see the same thing over here. I'm seeing log a of a raised to the x plus y. The outcome should be equal to what? X plus y. So in other words, what we are saying is that log a m times n is equivalent to x plus y, which is equal to, well, x was defined as log a m plus log a n. So log a m times n this is what we are calling the product rule. Okay, so what is this trying to tell us? That if you have a product of terms or factors, then you can split them into the log of their individual, the sum of the log of the individual factors or terms. Right, let me take it again. If you have a log of base a of the product of factors or terms, then you can split them into the sum of the log of the individual factors in that product. Okay, now let's look at the second one. So the second one is called the quotient rule. So quotient means we're dividing. So we're looking at log a and n and we're trying to figure out what this is equal to. So again, I'm using the declaration that I started up at the very front, knowing that x is equal to log a of m. That is the same as a to the x is equal to m, and y equal to log a of n as exponential as a to the y is equal to n. So if I substitute these the exponential form for m and n back into the quotient, then I see log a m over n is equal to log a to the x over a to the y. And again, I see an opportunity to utilize my rules of exponents over here, which is if I have the same base and I'm dividing, I want to subtract the powers. So in this case, I end up with log a x minus y. Now, if you go back to the property number 3 one more time, log a of a to the x is equal to x. So similarly, as we did with the product rule, log a of a raised to the x minus y becomes what? X minus y. All right, so we are saying that log a of m over n is equal to x minus y. Well, we can replace what x and y are because we know what it is in terms of its log. So log a m over n is the same as x is log a m minus log a to the n. So that becomes the quotient rule. So what does the quotient rule state? It says that if you have the log of a quotient m divided by n, then what happens is that you have the difference of the term in the numerator, the log of the term in the numerator minus the log of the term in the denominator. All right, let me take it again. If you have a log a of m over n, then you are taking just the difference of the log in the numerator and the log in the denominator. Okay. Okay, let's look at the third one. The third one, I'm going to call the power rule. Okay, so it says log a of m raised to the c. What do you get? So in this case, I'm only going to use just x is equal to log a to the m, and that's the same as a to the x is equal to m. So if I substitute the exponential form for m, then I get log a to the x raised to the c. Well, if we apply our rules of exponent, which says that if you have a base raised to a power, then you can multiply the powers together. So you end up with log a to the cx. So again, I run into the property number 3, where it says log of a base of the same base raised to cx. The outcome should give me back cx. So it looks like, well, let me put this over here so that we are very consistent with my definition so far. Okay, so we're saying that log a m to the c is equal to cx, but cx is the same as c times, and x was log a to the m. So we are saying that if you have a log base a and you have a factor raised to the c, or a term raised to the c, then all you need to do is just drop the power down in front of the log as a product times log a of what? Log a of m. All right, so that becomes the third property. All right, so these 3 laws plus the properties together give us enough tools or skill set to help us to manipulate so many different things. And in the next video, we'll look at those examples so that you get comfortable working with these laws and properties. All right, the last thing I want to talk about is something called a change of base. And basically, a change of base is that we learned so far that we can have a log of any base, right? As long as it's greater than a is greater than 1, we can have any base that we want. But we also have some classic bases that we like to use, like base 10, the common log, or base e, our natural logarithms. So if we have an opportunity to be in those bases, we like to work in those because it's easier to intuitively think about how to manipulate those. Certainly, you can also have an opportunity to work in any base that you want to work in if that is going to help you resolve the issue that you're handling. So a change of base just gives us an opportunity to switch bases to enable us to do what we need to do to solve our problems. Okay, so let's see how a change of base works. So we have y is equal to log a of x. And I want to try and switch the base. Switch base a to a different base. So to do that, I need to switch things back into exponentials. So if I switch things back into exponential, I get a to the y, a raised to the y is equal to x. And then I'm going to apply a log, because a log allows me to have a base, and I can now choose whatever base that I want. So I'm going to apply log base b to both sides of this expression here. So I'm going to get log b of ay is equal to log b of x. So on the right side, on the left side, I have an opportunity to apply this third property, the power rule property, on the left side. It's log b of a raised to the y. The property says that I can drop the power in front of the log, and that will resolve what I'm trying to do over here. So here, if I drop the power, I get c times log b a is equal to log bx. Sorry, in my case, I did a boo-boo over here. Supposed to be y. Okay. Now let's solve for y, and you see something happen miraculously here. Bx over log of ba. Well, remember that y is this buddy here. So we are saying that, in other words, we are saying that log ax, if I want to switch the base, log a of x, if I want to switch the base, in this case to base b, then it would be log b of x over log b of a. So you can think about it as if you want to switch base, well, you get log b of the argument divided by log b of the base of the original log. Now, this is the expression for a change of base. So let's look at two classic situations. Base e. So in this case, log a x is going to be equal to log e x over log e a. If you recall, we said log e is a nice cool way of saying natural log. So this comes out to be the same as ln x over what? Ln a. So you can also take log a x, if you desire to be in base e, then this is what you get for your outcome. If you are in base 10, then log ax is the same as log x divided by log a. Remember that a log without a base is base 10. So we can also see that you have a log of any base of x, you can write it, you can do a change of base in base 10, and it will look like log x divided by log a. Certainly, you could pick any base. So if I was interested in base 5, then log ax will be equal to log base 5 of x over log of base 5 of a. Okay, and I mean, some of you might ask, what is the usefulness of this? And like I said, sometimes maybe you desire to work in a specific base because you are comfortable in that base. So we're comfortable in base 10. We see what's going on. Sometimes too, it might be that you have a function and you're trying to use your calculator and you don't have enough functionality in your calculator, but you can do a change of base that will allow you to use the functionality that is in your calculator to what kind of break down the problem that you're trying to solve. So every now and then you might see a change of base in your work, and you should know how to switch them from its old base to the new base that you desire. All right. So in my next video, we'll kind of run through some examples of the properties, the laws, and a change of base to get you comfortable to how you handle these. See you in the next video.